So here's a fairly easy one. It says find and evaluate the partial derivatives with respect to x and y at the point x is -2, y is 1, z is 3, and then what do they mean? And our function is given as h of xy equals x squared minus y squared, and we want the partial derivatives. By the way, notice that if x is -2 and y is +1, this is 4 minus 1, so z is indeed 3. So what do they mean? Well, let's find the partial derivative of h with respect to x. That would just be 2x because we treat y squared as a constant. And so that's to be evaluated at the point where x is -2 and y is 1. So that partial derivative is -4. I'll talk more about the interpretation when we look at the graph here below. Partial derivative with respect to y at the same point. Well, the partial derivative is -2y, but at the point where x is -2 and y is 1, that would be -2. So here on our surface, let me see, x is, x is -2, y is 1. So when x is -2, by the way, this is a hyperbolic paraboloid, x is -2, y is 1, that point would be out here somewhere, okay? Now in the plane where y equals 1, that would be the plane that goes through this line right here, right? I can't draw it on here, I'm sorry to say. But in that plane, at this point, the surface has a slope of, I'll turn it sideways maybe so you can see it, a slope of -4. That's what this partial derivative equal to 4 means, okay? So now the partial derivative with respect to y. Let's look down on it so we can get the point properly. Let me see, x is -2, y is 1. That would be about here. I think, yeah, maybe here, right? This is it right here. X is -2, see, x is -2, y is 1. And so in the plane where x equals -2, so in this plane, the slope of the tangent line is -2. So very cool. And I think I tried to illustrate this one. This graph doesn't rotate, unfortunately, but I think you can see the purple one, the lavender one, is the partial derivative with respect to x, and the whitish one is partial derivative with respect to y.